River deltas, like the ones seen here on the Au Sable River, are dynamic places where fast-flowing water from upland watersheds deposits suspended material into slower-moving waters, like Lake Champlain. The deposited material forms the bottom and sides of the river channel, often creating an extended deposit along either side of the river channel out into the lake, seen here as bars or spits. River deltas usually include a fan of material spread out from the mouth, often seen from the air. On delta floodplains that are broad and flat, rivers can and do meander. The Au Sable River spills out onto a broad, flat, sandy floodplain where the river has meandered significantly. The Au Sable Delta has two river mouths actively depositing sediment, and they may alternate which is depositing the most sediment based on which is carrying the most water volume. River levees paralleling the channels and cut-off oxbows are evidence of the regular migration of the river channel across its floodplain. Deltas often include adjacent floodplains, in addition to the more obvious sandbars and spits at the outlet. These seasonally flooded plains may form extensive wetlands, often containing levees and backwater sloughs. Water levels within the delta can vary widely throughout the year, depending on the amount of precipitation falling anywhere in the watershed. Suspended material carried by the river can be organic, like logs and foliage, or mineral, like rocks, sand, silts, and clays. Water velocity determines the size of suspended material carried by a river and the distance suspended material is transported. As velocity declines, sediments are deposited and often disturbed and redeposited in the shifting channels of the river delta. Storms can cause faster water velocities and increased flows, occasionally opening new river channels. The Boquet River occupies a simple channel that flows to its delta on Lake Champlain. There is evidence in its floodplain that the channel has shifted several times over the last 8,000 to 10,000 years, but the shifts have been minimal, perhaps only 30 to 50 feet laterally. If you walk a path across the floodplain near the mouth of the river and perpendicular to it, you will cross alternating ridges and depressions that are oriented parallel to the river flow. These are remnants of old river channels that have been abandoned and now serve to carry water only during extremely high water events. The Boquet River is more or less restricted to its single channel because it is constricted by a bedrock ledge upriver. Compared to the Boquet and Au Sable River deltas, the delta of the Missisquoi River on the Vermont side of Lake Champlain is much larger and more complex. The Lake Champlain Valley generally rises more abruptly on the western New York shore than on the eastern Vermont shore. The Vermont shore has been extensively converted from pre-settlement northern forest to today's agriculture and residential developments. Consequently, the Missisquoi River flows for a longer distance through an agricultural and developed landscape, resulting in higher sediment volumes than any other river flowing into Lake Champlain. We see here at least 4 river channels of the Missisquoi River Delta, 2 primary and 2 older, with dramatically reduced volumes, slowly blending in with adjacent wetlands and the old levees. And these are only a portion of this complex river delta. Sediment deposition within this delta is also complex, and there are indications that streams branching off and flowing away from the mainstream channel within the delta, like Dead Creek, are depositing sediments at higher rates than the main channel and extending deposits more quickly out into Lake Champlain. Dissolved nutrients transported by these rivers are absorbed by sediment or by the floodplain and riverbank vegetation. Excess water volumes are temporarily stored within the floodplain and between the levees. Deltas are places in a constant state of change. As water volumes and levels vary, sediments are deposited, eroded, and redeposited. Each river delta has a unique form because of the hydrograph of the river forming them, the surrounding topography, human impacts within the watershed including dams, roads, agriculture, development, seasonal precipitation, storm flows, and the underlying geology of both the watershed and adjacent floodplains. Delta water levels can also be affected by lake levels. Lake Champlain is a large, long, and narrow north-south oriented lake with many major river inflows affecting lake level. If the lake's water level rises due to inflowing waters from its watersheds, water can back up into all of its deltas. In addition, water levels on all of the Great Lakes, including Lake Champlain, can be affected by a drop in atmospheric pressure raising lake levels, or wind-driven displacement of water within the lake's basin, causing water to back up into its downwind deltas. River deltas are like living organisms, constantly growing and changing shape. The deltas we see today will become larger and more complex landscape features hundreds and thousands of years from now.